If tenant isolation lives only in Python, it will eventually leak. Move the boundary into the database. This is the pattern you'll be able to implement by the end, which sets a tenant guardrail and answers a question using only that tenant's content. I'm Professor Pi, teaching AI engineering and LLM systems with simple Python. Most RAG systems keep tenants isolated in application code. That feels fine at small scale. But when services multiply, background jobs run, or a bug slips in, Python only checks leak results across customers. The practical pain is either data exposure or a maintenance nightmare where every access path must replicate the same checks. Success is when a single database layer enforces tenant scoping, so every query, search, and insert automatically respects the tenant boundary without repeated checks in code. The intuitive idea is to push tenant identity into the database session and let the database refuse anything that does not match. Imagine setting a tenant value for the session and then discovering that all reads and writes automatically filter by that tenant. The strength is simplicity and a single enforcement point. The trade-off is you must manage session settings carefully so they do not persist across unrelated requests. We will build a tiny Postgres-backed RAG demo that stores three-dimensional embeddings, enables server-side similarity, and uses row-level security to lock every request to a tenant. That way, the same retrieval code returns different documents depending on the session tenant, with no application-side filtering required. Now we will connect to Postgres and enable vector support. This snippet connects to local Postgres with psycopg and enables the pgvector extension. The import brings in psycopg, the official Postgres client for Python. The variable con opens a database session, and cur creates a cursor to run SQL. The call cur.execute with create extension ensures pgvector is available, which adds a vector type and similarity operators like the L2 distance operator for retrieval. Finally, the print shows a boolean based on con.closed to confirm the connection is active. Seeing pg connected equals true confirms we can now issue pgvector queries from Python. Next, we will create a tenant-aware storage table for documents and embeddings. This example creates a docs table in Postgres to hold tenant-scoped text and pgvector embeddings. The cursor cur executes a create table with 4 columns: tenant ID for isolation, doc ID for identity, content for raw text, and embedding as a vector with 3 dimensions. The vector3 type comes from pgvector and will store small numeric arrays for similarity search. The next query checks information schema to verify that docs exists by counting matching table names. The fetch1 call returns the count, and the print shows how many such tables are present. A value of 1 confirms the storage for RAG embeddings is ready. Now we will enable row-level security and install a tenant policy. This code enables row-level security in Postgres and installs a single tenant policy. The first execute flips RLS on for the docs table, so all access must satisfy a policy. The create policy statement defines p-all for all commands, using current setting app.t with the true flag to read a session-scoped tenant value, using applies to reads, and with check enforces the same rule on writes. The true flag makes missing settings evaluate to null, which safely denies access by default, rather than accidentally allowing everything. A quick query of PG policies confirms the policy was created. The printed count proves RLS is active and guarding every operation on docs. Next, we will scope a session to tenant T1 and run a vector search to prove isolation. This snippet scopes the session to tenant T1 and performs a pgvector search. The set command stores T1 in the Postgres session gucapp.t, which the RLS policy will require on every access. The insert adds one row for tenant T1 with a small three-dimensional embedding. The select orders rows by the pgvector distance operator between embedding and the query vector, returning the nearest doc ID. The fetch1 call provides the top result, and the final print shows which document is retrieved. Seeing best T1 equals D1 confirms that retrieval is tenant-scoped, and the policy permits only T1 content. Now we will run the same retrieval pattern, but scope it to tenant T2 only for a single transaction. This example uses Postgres setLocal to scope tenant T2 for a single request and validates safe retrieval. The with block makes a fresh psycopg cursor tx, then set local app.t equals T2, binds the tenant GUC only for the current transaction, preventing cross-request leakage. The insert creates one T2 document with an embedding. The select performs the same pgvector nearest neighbor query, but RLS restricts the search space to tenant T2, so only T2 rows are considered. The fetch1 result is printed. Seeing best T2 equals E1 proves identical retrieval code returns different tenant correct results by construction. Using set, not local, would persist longer and risk leakage. Optionally, imagine mapping this toy to a real service. Each incoming request sets the session tenant before any queries. Background workers open fresh transactions and must set local tenant per job. The database enforces the guardrail, while your application stays focused on embeddings and prompts. Recap: what it is, when to use it, and one caveat. What it is: server-enforced tenant isolation using session tenant values and Postgres Row-Level Security with pgvector for similarity search. When to use it: whenever multiple customers share a single embedding store and you need a single enforcement point for security and correctness. One caveat: session settings must be managed carefully, so tenant values do not persist across unrelated database sessions or requests. Next step: add an ANN index in pgvector and tune its search parameter EF_search to speed larger similarity queries while keeping tenant filtering enforced. If short practical AI engineering helps, subscribe and watch the AI engineering videos.